Let's talk about animation for processing. Now, animation has a huge and fascinating history, and there's a million things to talk about in animation, and I'm not going to talk about any of them. We're just going to focus on the few things that are essential for us when we create animation with processing. This central fact of animation, which is probably not too much of a surprise to you, is that when we watch a piece of animation, in fact, nothing is moving. What we're watching is a series of still images that are shown in very rapid sequence to create the illusion of motion. Here's a picture drawn by Leonardo da Vinci, who had an astounding ability to visualize very complicated motions as they were happening and then draw them. That's a very specialized skill, and most people don't have it. There's a very famous story that in the 1870s, Leland Stanford, a former governor of California, had a bet that when a horse raced around a track at a full gallop, its four legs came off the ground at the same time. No one was quite sure how to settle the bet until Stanford hired a man named Edward Muybridge to take a series of photographs of a horse running at full gallop. These are the pictures he took. And as you can see in the top row, in the middle two frames, the horse's legs, in fact, all leave the ground at the same time, and that settled the bet. But this gives us a window into animation, because if we take these 16 frames, which were shot very nearly one after the other, and play them in sequence, we get something that almost feels like it's in motion. Now, depending on exactly how large this is on your screen and maybe some compression artifacts, it will look more or less smooth to you. On my screen, it still looks a little bit jerky. I don't get the feeling that this is fluid motion, but it's close. And if we had more frames and showed them more quickly, one after the other, it would look more and more smooth. Now, Muybridge went on to take many very famous image sequences. He took sequences of other animals, he took sequences of people doing things, but all of the images we've just seen have a similar characteristic. They're sequences of images that, when we show one after the other, capture motion. Now, there's a whole other way to go to try to capture motion, and that's to just open up the shutter and let things happen. And as objects move, they leave a trail behind. Well, there's sort of an in-between point between these two extremes, and that's to set up your camera in a dark room, open up the shutter, and then fire the shutter periodically as things move. You'll get an image like this. This is a multiple exposure of somebody running from right to left. Well, if you're very careful about your exposure settings and how you shoot things, you don't even have to be in a dark room with a strobe. You can do this sort of thing outdoors. And if you're very clever and maybe do a little bit of post-processing, you can get a spectacular image like this, where we have 6 separate images of this fellow surfing from right to left, all captured in one picture. But of course, this doesn't give us the illusion of motion. It shows us the path, but we don't actually feel like anything is moving. To get that, we need to show a series of frames one after the other. Perhaps the most straightforward way to do this is to make a flip book. A flip book is just a whole bunch of pictures stacked up, bound, and then you flip through them, typically with your thumb, from back to front, and the pictures change. Here's a typical flip book, and you can see it's held together on the left with a couple of very long screws. And then to see this animation, you just flip through it with your thumb back to front. And depending on the speed with which you flip, you can control the speed of the movie. Now, probably the simplest version of this approach is something called a thaumatrope. And it's a great word for a very simple thing. A thaumatrope is just a little piece of wood. It doesn't have to be wood, but here it is, with a string tied on the left and the right. And here's a very famous example of a thaumatrope. We draw an empty cage on one side of the wood. On the other side, we draw a bird. Now we hold this up in front of us, pull the strings taut, and spin the strings between our fingers, causing the piece of wood to flip end over end over end over end very, very quickly. And if we do that, what we see is the bird in the cage. Even though there is no picture of the bird in the cage, what we're seeing is both images simultaneously. The thaumatrope works because of how our brain is wired and how our visual system is set up biologically. It's just there are some properties in our visual system that if we exploit them, we can create this kind of an illusion where the bird and the cage exist in our visual field simultaneously, even though, of course, they never do. There have been a whole bunch of technologies designed to exploit this phenomenon. One of them was called the zoopraxiscope or phenakistoscope. These things have great names, and there's a long history of these oddball technologies that people explored trying to create animation. So here's a zoopraxiscope, actually from Edward Muybridge, the same guy who shot the horses and the dogs and the pole vaulters and all the others. And this is a series of 13 images of a couple dancing. The way this works requires a mirror. Here's an example of someone holding the disc on a piece of wood, and the disc spins around the top of the wood. Now, as you can see, the picture is facing away from the man, so he can see it in the mirror. But he can only see it when one of the little slits that's cut into the disc happens to be in front of his eye. So imagine he's looking at one of the slits just to the right of the pivot. When the slit comes around, he can see through the slit, he sees the mirror, he sees a picture in the mirror. Then the slit moves on and he's looking at the back of the card. It's just black. Then the next slit comes around. He can see through it. He sees the picture. Then it's black. Then he sees through the next slit. And in that manner, he sees the pictures one image at a time, only when the slit comes around. And so he doesn't see all the pictures smearing together and blurring. He sees a sequence of still images separated by black. In part 2, we'll spin this disc and see it in action.